Hello, today I'll be going over this device, the ARDSEQUINO. This is an open source project that I've released. I developed this project solo, so everything you see in this video, including the code, electronics, and enclosure, were designed, built, and assembled by me. The ARDSEQUINO is a MIDI controller with a built-in 14-note polyphony sample player. It can sequence up to 384 steps. An arbitrary number, I know. The interface features 14 keys for playing sounds, 3 keys for controlling the sequencer, 3 rotary encoders for controlling various settings, and 4 rotary potentiometers for controlling track volume, global volume, attack, and release. This device also features both MIDI in and out in a 5-pin format, mini USB power, an SD card slot, and a 3.5mm headphone out. Ignore the barrel jack. I've since removed that from the official documentation, and it's just an artifact from development. Now, let's plug it in. I'll quickly walk through the various features before jumping into a demo. But if you'd like to skip straight to the demo, just jump to this timestamp. The bottom 14 keys, as you can see, play sounds. They're actually assigned to MIDI notes, so if I change the MIDI channel, sounds will no longer play because the sample player is currently set to respond only to messages on MIDI channel 8. The first 7 LEDs on the bottom 2 rows correspond with a key. This is important for reading the sequencer later. As you just saw, I pressed this button while rotating this encoder. The dark blue key is a shift button when held, and switches menus when short pressed. I'll come back to that in a bit, but first, let's go over the functions of these encoders. This encoder sends program change messages, and its shift function controls the global MIDI channel. This encoder changes the sequence length, and currently has no shift function. The last encoder changes the BPM, and its shift function controls the per beat note division. Pressing this encoder will flip the BPM, resulting in reversing the sequencer. The red key is the record button. You can sequence step by step or while the sequencer is actively running. While recording is on, this little LED will blink. The green button is the sequencer play pause button. This LED icon means that the sequencer is paused. Using Shift, these 2 buttons can also be used to quickly navigate through the sequencer steps. The 4 LEDs on the bottom right corner denote which page you are on. The top 4 knobs are potentiometers. From left to right, they control track volume, global volume, attack, and release. Now, to dive into the secondary menu. This menu is the per key parameter menu. As you can now see, a specific key is displayed on the LED. Simply press a key to select it. One feature I didn't mention earlier is that if you hold Shift while pressing one of these keys, the sound will not be played. That way, parameters can be tweaked without disrupting an active sequence. The left encoder now controls the MIDI note value of the selected key. In the case of the built-in sample player, each MIDI note value corresponds with a different sample file. The shift function of this encoder changes the MIDI channel for a key. This allows you to sequence up to 14 MIDI devices with 1 key per device. Pressing this encoder will perform a parameter reset for the selected key, which resets its volume, syncs its MIDI channel back to the global MIDI channel, resets its probability, and disables the note offsetting. This encoder sets the probability of this key playing out in a sequencer. It'll be easier to demonstrate later. Pressing this encoder will toggle the note offsetting. This means that when a key is released, it sends a note off message. By default, releasing a key will not prevent a note from playing out. And currently, the last encoder does not have any functionality programmed yet. That's pretty much all the features as of the version 1 release. If you'd like to learn more about this project or make one yourself, check out the link in the description. It links to the project GitHub page where you'll be able to find more project details, build instructions, source code, and more. Now, onto the demo. I'll fast forward through the next bit, where I select my samples and arrange the sequence. Okay, I've selected and sequenced some samples. I'll start by playing each sample out. Now, I'll play the sequence. As you can see, I've gone in and changed the probability for some of these steps. So now, even at 32 steps long, the same pattern will rarely play out twice. With that, this demonstration has reached its end. Feel free to ask questions in the comments below or through the GitHub page. Thanks for watching.